into the details, but it uses the same basic operation, right? So this is an operator, A times Q. You never have to, theoretically, never have to build the matrix A at all. You just have to provide this operator, matrix vector multiplication. And so Anasazi is a framework for which has eigensolvers, but you can also define your own eigenproblems and then solutions to those eigenproblems, so you can extend it with your own eigensolvers. It's a very powerful mechanism. Like I say, it has some turnkey eigensolvers included, like Bloch-Davidson, Bloch-Krylov-Schur. If you don't know what these are, that doesn't matter. They're just state-of-the-art eigensolvers. Similarly, Knox is another library which incorporates this COCOS model, this time for nonlinear equations, nonlinear equation, right? Basically, you're trying to solve this, and providing the Jacobian first derivatives, matrix of first derivatives. It can be very performant if you make the right first guess. There are interfaces. Again, Petsy and Trilinos have mutual interfaces, so you can go from one to the other. This, again, is a very powerful library for nonlinear equations, which conceptually, at least, can be used on GPUs. So, Trilinos Summary, it's a non-monolithic set. It's not like Petsy in that sense. It's just individual packages to solve fairly well-defined problems, engineering and physics problems. Some of them interoperate very well. Some are loosely connected, and some of them aren't connected at all. They just happen to be developed at the same institution. It's a large development team. It's free software. It's technically at a very high level. There's a big user community. Incidentally, there's a Trilinos user group meeting coming up in Lugano in June, if I'm not mistaken. There are bugs in Trilinos, believe it or not. And the solvers are extremely opaque. And if you run into a bug, it's very difficult to then ascertain whether you're doing something wrong or whether it's Trilinos which is doing something wrong. The GPU implementation is through this COCOS extraction, but only for a fairly small number of the packages. Okay, so I am at the end of the talk, right in time for lunch. What's the take-home message of all this? Very simple. Don't recreate the wheel. If something is available in libsci, use libsci. If something is available in thrust, use thrust. Don't go out and try to do something which other people have done better themselves, right? There are a limited number of GPU libraries available, right? I mentioned the significant ones, the COO, XXX from NVIDIA, Thrust, VNSCL, etc. As far as distributed memory libraries go, there are some developments for distributed magma. We're still waiting. There's Petsy, which has active development, PD problems, this monolithic library. Trilinos team at Sandia has extensive GPU efforts ongoing, but the current status is rather sobering, okay? We need more development efforts. There's not so much which can be actually used on Piz Daint today. So please tell us what you need, and Alfio already mentioned, there are resources available to work on this. Let us know what you need, and so we can, try to realize those needs. So a lot of people helped out here. People in the Petsy team, Trilinos team at University of Tennessee. Thanks to you for listening.